Hey, this is OXDF, and today we're looking at day 16 of the 2016 Advent of Code as part of the 2023 Revival of Code, Dragon Checksum. Let's check out the challenge. So again, there's some story like usual, but this puzzle really breaks down into two pieces. You're going to get given, let's kind of look at some puzzle input that looks like this, as well as a length. So like this length and 272. In the example, we'll do this with the length of 100. And the first thing you do is expand your input until it's bigger than the length you're given. And the way you expand it is you create a copy, you invert all the ones and zeros in the copy, you reverse the order of the copy, and then you go original, the number 0, and then the copy. So 5 ones becomes 5 ones, the number 0, and then this right here is the 5 ones inverted and reversed. Reverse doesn't matter. So here's a better example. You have all of this. All of this becomes this up through here, there. Then there's the number 0. And then this is like this 1 is the inverted 0 here. This 0 is the inverted 1, etc. All the way to the 4 inverted 1s here come out here. And so that's how we're going to expand. And we do that until we're bigger than our length. Then we need to calculate a checksum. And to calculate a checksum, we're going to take each pair. We're going to work from left to right, taking pairs. And so they tell us to say, like, so you start with this 1, 1. Basically, if the two numbers in the pair are the same, you reduce them from 2 bits to 1. So it's going to go 1, 1 becomes a 1. 0, 0 becomes a 1. 1, 0 becomes a 0. So you can see the output coming out here, 1, 1, 0. Let's see, so then we're here, 1, 1, that becomes a 1 because they're the same. 0, 1, that's a different, so it's a 0. 0, 0, the same, so it's a 1. And then you want your checksum to always be odd length. So if you end up with an even length, like this one's 6, you do the same process. So now you're going to say 1, 1, and again, that becomes 1. This is supposed to be 1, 0, 0, and that's where you see this 100 come out, and the checksum here is 100. So we need to do this kind of iterative thing to do checksums. Right away, and I did when I read the I read the problem and I played with this a little bit before looking at the thing. I have a suspicion that we can do this in one pass, and we can do this in one pass. So we're going to take advantage of that when we do the checksum, and that is to say, if we can calculate the length of this, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So every time we can figure out we can definitely figure out the end length of this, right? Because 12 divided by 2 is 6, divided by 2 is 3, is even. So we can, if we factor all the 2's, if we count how many 2's are in this, the length of this number, we can definitely right away know how many is going to go into it. But the more other thing we can think about is, because the same is really just even and odd, if we can look at these 4 bits right here and know that this is going to become 1, 1, which is then going to become 1, because no matter what, for any of these 4 bits, this is going to become 1, 1 if the number of 1s is even. And you can do some playing with this on your own, or you can just trust me on it. But for example, this is going to become a 1 and a 1, and the 1, 1 becomes 1 again. Let's say it was like, instead it was 1, 0, 0, 1. Well, those would both become zeros, and because there's only enough, you're only going to get the number of 1s out there. I don't know how to explain that great, but trust, you can play with it a little bit, do some pen and paper. It works out. So what we can do actually is figure out the number of 2's, and then figure out how many are going to go into the end result, and then we can just look across that and see if it's odd or even, and then use that to figure out whether it's a 1 or a 0. So by that logic, we take all 4 of these, and it's even, so it becomes a 1. Take all 4 of these, there's 3 1's, odd, so a 0. Take all 4 of these, 1, 1, odd, 0, and that's where we get our 100, which is down here. All right, that's enough algorithm talk. Let's do some code. I'll use my genday script here to do day 16. A video where I describe exactly all it's doing, but in general, we got some stubs. We got our input, which in this case we could probably not even use, but we will. We will start by writing some tests, and if we think about what we want to do, we're not going to need this imported from a file thing. The first thing I want to think about is let's start with a test. Let's see. We need to do expand and we need to do checksum. So we'll start with expand. Oops. See, I'm going to try to mess this up. Leave that undone, and I'm going to go ahead and start here with a def test expand. And we'll take, I guess we'll take puzzle input expected pass for the moment. So we can come up here and we can get the example. I'm going to do this again, move this onto another window so I can easily copy and paste from it. And let's make some examples here. So if we expand the number 1, it's going to become 1, 0, 0, right? Because we take the copy, invert it. If we do 1, 1, 1, 1, I better just grab, well, we can do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. We knew that one. I'm going to grab this other one off the page. Let's see, oops, I copy that. So we got some examples here of what expand looks like. And so now we can say aoc.expand puzzle input equals expected. And before we show our test failing, let's at least come in here and do a def expand s. We can even just put a expand string based on dragon algo. Sweet. Okay, so now if we, I will come here and just run it out of here. I'll use my PyTest. I have a video where I show how to set that up as well. I'll include a link here. And now if I hit F5, we run our tests and we see we are passing. That's unexpected. You should not be passing. That's weird. Let's see what's going on here. I put a breakpoint here. We can play. Let's see. So puzzle input is 1. Expected is 100. aoc.expand puzzle input is nothing. Okay. This is fun. Silly thing. Just forgot to put assert here. So we were just making a Boolean there and not worrying about it. So now if we run this, we don't need this breakpoint. We can continue, and we are getting some fails of none equals 100, blah, blah, blah. Okay. I guess that's an interesting lesson. So now we come up here and start to do this. We can actually make this. Actually, I don't think it's gonna be too hard, right? So what do we want to do? We want to make a, let's see, return f. We might be able to do this in one line. I like doing that. So if we're going to return the string, we're going to return the 0. We're going to return the string reversed. So like that's how we take the string in reverse order. And then we just want to do, I think it's, let's see if we can figure this out without looking it up. Translate string.makeTrans 0, 1, 1, 0. I think it might be as simple as that, although Python looks unhappy with me here. Oh, I've got this quote. I gotta switch my quotes here. Let's try that. We could be solid right there. Yeah, sweet. So we've got an expand function. It's working entirely with strings. I don't know that it's gonna be super slow. I'm expecting, by the way, you know, our puzzle input was to like get to 272 big. I'm assuming we're getting something huge in part 2, so algorithms will matter. But yeah, okay. Let's see. Let's do it while we're here. We'll do a def checksum because we're definitely gonna need that. Let's add a string here. Generate checksum based on. I'm not really sure which one of these is the dragon algo, but we're gonna just keep going with that. So if we save that, now we can come back over here and work on our test for checksum. And so, test checksum. And I'm going to be a little bit lazy here and just grab one of these. Let's see. I'm not sure how many we even have. We know that assert, so let's not forget that this time. aoc.checksum on the string that is equal to 100. So let's start there. We can work off that for now. We've got our here, so none equals 100. Perfect. Let's go back here and do the checksum. So we talked about the algorithm earlier. We're going to get the number of 2's in the we need to figure out the number of 2's in the length of the thing. How many times can we divide it by 2? In fact, maybe we should do a function for that as well. Def num2's on I don't know if that'll work. And so how are we going to do that? There's a couple different ways to do it. My favorite way, honestly, is to look at the bits, and work off of that. So if we say bits equals, I think there's probably a better way to do this, but I always do it by just making a format string, not n. Well, actually, n's better than I. Let's do n. So now we get the bits of this, and the way we can tell how many times it divides by 2 is the number of zeros at the start of this. So we can do a really simple. This is I don't know if this is actually good or not, but we'll go with the length of bits minus the length of bits dot rstrip, which is going to take characters off the end. So in this case, removing all the 0 characters from the right side until it hits something else. And so this will tell us exactly how many 2's there are. Shoot, we should have written some tests for this. Let's come down here and do that. Def test num2's. And we better parameterize this one. PyTest mark. That's not PyTest. Mark dot parameterize. We'll call it num and 2's. We can do like so. The number of 2's. Actually, this will be fine. So the number of 2's in 1 is 0. In 2 is 1. In 6 is 1, right? Because 6 divided by 2 becomes 3, but then we're done. In 4 is 2. In, let's pick a big number, like 12 is 2. And then like what's, let's see, 64, we'll just do it like 64 times 3. And that result will be 8. Right, 2 to the 4. So 2, 4, 8, 16, 32. No, it's 6. Yeah, obviously 8 is 256. That seems like enough for now. So we'll have num2's, and now we can just do assert aoc dot num2's on num equal to 2's. Now if we F5 this, we wrote the test in advance, but we're already passing them all. We're still failing our checksum one, but we're passing our num2's. So we did that in the wrong order, but we're good. Okay, so we have a good function here. Now from the checksum, we can say like 2's equals num2's on len s. So now, what is the checksum? So we are going to do, and this is, we're going to get, I need to grab, I'm starting to have this memorized, I think. So we want to grab these in groups of like the number of 2 to the number of 2's, right? So if there are if there's 2 2's in there, right, and we want to grab them 4 at a time. If there's 3 2's, we're going to actually grab them 8 at a time, because that's how many we're going to do. So we are going to do our zip, and this I have a video where I go into detail of exactly why this works. Zip iter of in this case, it's going to be the string. So we're going to be going across the string, and we need to be 2 sides of the tuple. Okay, that times, in this case, we're going to do pow 2 2's, like this. And this is going to give us an iterator that gives us the characters out of S this many at a time. So if 2's is 2, we'll get 4 at a time. If 2's is 3, we'll get 8 at a time. So now we can loop over that. We'll say like G for G in. So now we're going to get this. So now G will be those groups of things. So what are we going to do with each group? Well, for each group, we want to figure out if it's odd or even number of bits. And so I'm going to do, let's see. So in this case, we'll do something else around here. We're going to do B for B in G. So we're going to get each bit. And we could like convert it to an int, So now we have literally ones and zeros. In fact, now we can sum that because the number of ones is going to be the sum of that. So now we're going to have, that'll give us the number. And then if that number, we need to really take that number mod 2, right? Because we just care if it's odd or even. We don't care what the number is. Now we have a 1 if it's odd and a 0 if it's even, but we need the opposite of that, right? We need 0 to become 1 and 1 to become 0, so we'll do 1 minus that. That's a lot there, but hopefully that makes sense. We can, we're going to get the number, sum up all the bits, so that'll give us a number of ones. We then mod 2, so that'll tell us, 1 if it's odd, 2 if it's even. But then we want to say 1 minus that, so 1 minus that 1 becomes 0, and 1 minus 0 becomes 1, so we've inverted those. Now we need to convert that back to a string. And we're still working on each G here. I think that's what we want to convert to a string. That work? Yeah, I think that's good. And then we want to dang.join. So we want to take that string and put it into a big string, and I think we're just done. We can return this. Let's try that. That might be a mess. We might need to do some troubleshooting. No, we did it. It works. So that is not great code, but it's it's going to work for me. So I think we're in good shape. Cool. So now we want to do part 1. So let's come here. We think we have all the pieces. Let's come down here and we can get rid of this. We can just put some data in here. We don't have that many examples. So basically our test is going to be, we want to run, I'm going to call this like run, we can call it part 1 for now. AOC.part1 on, we build grab the string. I think it was, let's see, over here, I'm on the other screen. You'll have to forgive me for a second, but the example they give us is an initial state of this, and this is also going to have to take in a size. So for size 20, and we're going to get, we can, oops, let's just get rid of this. Initial state of this, size 20 equal to 0, 1, 1, 0, 0. And that's in the example. I just the screen. So if we F5 this, we should get a failure. And we don't have the part 1 set up right. Let's get that going here. So we don't need a parse function here. Get rid of my template here. We'll take this with an S. We aren't going to need that at all. We are going to need puzzle input data, comma. Why don't we, in the real problem, my answer is 272. I think that's none for now. I suspect we're going to end up calling it part 1. So now we're passing in the puzzle input along with 272. Here we're taking the string and size. Perfect. So now over in our tests, we can do string and size. Perfect. And so now we can start to do it. So what are we going to do? Well, if we need to start by while len s less than size, then we're going to s is equal to expand s. And so we'll just loop expand s until we get big enough, and then we can just return checksum of s. And then we need to do we need, I think I said this in the challenge, but we need to go just up to the amount of size here. We want exactly the full disk. I think we are good there. Let's give that an F5 and see if we run. And we're passing. Sweet. So if we come over here, change PyTest to current file, we will run with 272 this time, and we get back an answer. And now I will make sure you push. I know you want to see the gold star pop up. Let's be optimistic. And sweet. Okay, part 2. I don't need to pause this because it's not very hard. We just have to go to a much bigger length, and find the correct checksum. So this is really a test to see if we wrote fast enough code. We're gonna do a little refactoring here. We don't need a part 2. I guess we can leave this as, it annoys me, but we'll part 1 puzzle input this big. Yeah, we're gonna rename this. I don't like that. Yeah, let's rename. Rename symbol run, not solve, because I tried calling it solve in a previous challenge like this and I broke everything. Run. Sweet. We don't need any, we don't get any new data with tests, so we just have to work on bigger stuff. So there's no new tests to write, legitimately. And we can come here and run this and see if we get an answer in reasonable time. A little bit, I'm hopeful, but I'm not. I'm getting less hopeful as we sit here. Yeah. Okay. Let's take a look. I mean, we could let this run, but we're gonna take a look. I'm gonna put a breakpoint here and run. Let's see if we can figure out what's taking long. I mean, let's at least, is it the checksum or is it the expand? Where do we look? So we'll step in. Now we're here on the while length is less than size. I'm just gonna put a breakpoint here and hit play. Okay, so that was instant, right? So the expansion is not our problem. Our expansion is fast enough. What is len of s? Okay, that's fine. Let's go into checksum. Let's see. Let's play for a second. Is num2 the challenge? No, that's instant as well. So it's in this thing that's going crazy. This is our problem. Let's grab this whole thing. I think if I run this, it's going to take a long time. Okay, so we're hanging. Oh. It didn't take that long. That can't surely be the answer, can it? All right. We are one gold star closer. We fixed it. Why did that run so instantly, but checksum did not? Did I really just get a second gold star? I did. That's weird. I'm not sure what's going on there. I'm gonna cut the video off. All right, so I couldn't just let that go. I was just playing with this a little bit. There's a couple things I figured out. One, well, I'll say at a high level, one, this is not the fastest algorithm for doing this, but it's also acceptable. Two, there's a huge difference between running this through the debugger in VS Code and running it in straight Python. So I'm not gonna make you watch, but I just ran this through the debugger and I just let it go and I timed it with a stopwatch. And it took about a minute to finish through the debugger. If I come back here just into my terminal and I run Python day 16, oh, I should, hold on. I want to supposed to times Python day 16. 2.5 seconds. So a minute in the debugger versus 2.5 seconds. And that's with no breakpoint set, but just the hassle of having to run in that call environment, that they set up here with, well, you don't see it here, but that gets set up all this stuff with the launcher and the stuff adds the overhead. And I guess this must be doing something that's triggering that. So it's probably worth knowing that I want to run anything that could be computational intensive, make sure to run it just straight from the terminal. Even if it's in VS Code, just run it from the terminal and that'll make it faster. The other thing that I figured out is, oops, I didn't mean to do that. Let's close you. We're actually running over here. You'll be able to see. I'll leave it down here just so you can see when it pops up. I was playing with this a little bit, and I was wondering what in here could be taking so much time. And I won't go through all the details, but I think it's the string to int to string conversion for so many. We saw there's going to be, what, 3 million something things coming in here. So if instead of so really what we want to fix is there a better way in here to get the number of odd or even, bits. So rather than int b, and what I figured out is we can actually do, if we do so if we look at G here, G is going to be a array. Oh, we can see this did finish eventually. G is going to be an array of ones and zeros characters, right? And so if I take, if I do and join G like this, so I make a string. So now I'm going to have literally the bit string that it'll be if it's 5 characters long, it'll be 10101, etc. Right? If I then can get rid of replace 0 with nothing. So now I've got a string of just the ones. And now I can do a len on that. See if I can forgot if my parentheses line up nicely. If I do this len right here, mod 2, And then I'm going to take a 1 minus it here, just like I did before, and turn it into a string, just like I did before. If we come back here and run this, let's see if it actually runs. So we go from 2.5 seconds down to 0.6 with that. So that is certainly an improvement. And if they had given us a much bigger one, I don't know, 5 times faster, right? So anyway, I'm going to call it here. Thanks for hanging out with me today. I will talk to you next time.